All right, guys, we are doing section 1, 6 notes on angle relationships. The first part of our notes that we're doing is on angle pairs. The first pair of angles we're going to learn about is adjacent angles. Adjacent angles are two angles that lie on the same plane, have a common vertex, and a common side, but no common interior points. Okay? So when I'm looking at my first example, I want to identify that this angle is right next to this angle. They're sharing that side right there. They're sharing that vertex right there. So I would say angle ABC and angle CBD are adjacent. All right. Now the reason we say they don't have common interior points is because we're not trying to say angle ABD and ABC are next to each other, because they're really not. They would share a common interior area, and C would be a common interior point, and that is not what adjacent angles are. They're next to each other, they share that side, they share that vertex, but they do not share the same space, okay? So let's look at the next example. So the next example, we have the adjacent angles I see that are next to each other are ABC and CBD. So adjacent angles are ABC and CBD, or you can write DBC, it doesn't really matter. These are adjacent. So really you're just learning here, you're not going to say angle ABD, which is this whole area, is adjacent to ABC, because then they would share a similar common interior point, they would share a common area. That's not what adjacent angles are, just remember. They are right next to each other. You can see in this new example, oops, they share this same side, and they share B as a vertex, okay? So that's what's making them adjacent angles. All right, let's move on. So now we're learning about vertical angles. Vertical angles are two non-adjacent angles formed by two intersecting lines. Intersecting lines, okay. So from looking at my very first example, what I want you to see with vertical angles are they kind of make an X, and they make kind of like a V as well. So I notice this angle that makes a V also makes a V with this angle. So those two are vertical angles. I got angle AED is adjacent to angle BEC. Okay? One other important thing to know about vertical angles are they're always congruent to each other. Because you see these two lines are intersecting at E, so that's how it made those vertical angles AED and BEC. So that's a good thing to note. Vertical angles are always congruent. Okay? Now it's interesting, you'll notice there's another pair of vertical angles here. AEB, and hopefully you were able to identify that AEB and DEC are also vertical angles. So I'm going to actually just draw two congruency lines on those so that that says that these two angles, the red ones that I've outlined, are vertical and congruent, and that the green angles are congruent as well since they're vertical. Okay, let's look at our non-example of vertical angles. So these are not vertical angles because the lines don't actually intersect. you see they kind of stop here at E. If they kept going, that would be a different story. But there's no vertical angle over here that I could say that's a vertical angle with that, because it has just line segments going on. So basically this is a non-example because these lines don't intersect. Okay? All right, so we're moving on to linear pairs. So a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. So looking at our example, here is our line, right? Straight line. Then we have this ray coming out of it. So if our linear pair is a pair of angles whose non-common sides are opposite rays, then this would be a non-common side to this one, but they would make a pair on this line. So all I'm saying here is BEC and BED make a linear pair. So let's write that. BEC and angle BED are a linear pair. And just a fun note, linear pairs always add to 180. They might not necessarily look as perfect as this particular example, where they are on the same obvious line, but if this was like 80 degrees and it was separated from this 100-degree angle, if they add to 180 degrees, they are a linear pair. So linear pairs always add to 180 degrees, which is that line, right? It's 180 degrees. Let's look at our non-example for a second. The reason this is a non-example is there are no straight lines that continue like this one. And I don't know the measurements. I guess if this was 80 and this was 100, I can maybe say those are linear pairs, but at the same time, there are no lines here. These are segments that do not have a similar line. They're not a pair on a line. So this is not a linear pair because there is no line. So let's look at our examples. So we're naming an angle pair that satisfies each condition. So two angles that form a linear pair. So what two angles form on a line? So you can see here's a line right here, VW, and here's an angle on that line, and here's an angle. And I know that they are both on that VW line, and they both add to 180. So those would be considered a linear pair. So I'm going to write that. Angle VZW and angle XZW. Those are linear pairs. Another linear pair, just so you know, would be 115 and this 65 over here. Just because they're not connected, the fact is they add to 180, so they're linear pairs. This is a linear pair too. So there's a lot of linear pairs going on. Let me erase all that garbage. All right, now we're looking for two acute vertical angles. So I can see that this line, which is terribly outlined here, is crossing straight through this line. They're intersecting at Z. So since they intersect at Z, they kind of make that X. I can assume that this 65-degree angle is a vertical angle with this 65-degree angle because Z is that common intersection. And they're acute, right? They have to be less than 90. I could also say that 115, and if I added both of these together, this 115 is vertical angles. But we're looking for acute. So two acute angles that are vertical angles are angle VZY and angle XZW. Now the next question we can't answer, and the reason why is literally because we didn't learn about supplementary angles yet. It's down here. So we'll come right back to that. So let's look at D. Two acute adjacent angles. Remember, adjacent means angles that are next to each other, and they need to be acute, so less than 90. So two adjacent angles that are next to each other, that share a side and share a vertex, I could say, is this angle here and this angle here. I could also say this angle and this angle, they're both acute and next to each other. I could say this angle and this angle. So there's a lot of choices here. So let's just go with our initial one, this one and this one, right? So that would be angle XZW and angle WZT. Okay. Next, let's learn about complementary and supplementary angles, and then we'll go back to C and answer it. So a complementary angle are two angles whose measure is the sum of 90 degrees. You guys might actually remember this from previous learning. And supplementary angles are two angles whose measures form to the sum of 180 degrees. Let's look at an example of a complementary angle. So a complementary angle might actually look like this, a nice 90-degree angle. We know it's a 90-degree angle because it's got that lovely little square that shows us it's 90 degrees. But what if we have a bisecting line going through it? Well, maybe not bisecting, but a line going through it, and this is angle 1 and this is angle 2. Well, I can assume angle 1 and angle 2 are complementary because if I add them together, they're going to be two angles whose measure has a sum of 90. Okay? In supplementary angles, that's going to look something similar to what we've already looked at, which is called a linear pair. So a supplementary angle is also a linear pair. Ooh, okay. Also known as a linear pair. So you can see here that this angle, angle 1 we'll call it, just call it angle 1, and angle 2, those form a linear pair or a supplementary angle because if you add both of those together, they're going to have a sum of 180. So I can say angle 1 and angle 2 are supplementary. Okay, so let's go back to C really quick up here. An angle supplementary to VZX. So let's look at VZX. So an angle supplementary to that could be, this could be our line. So if we had this angle, maybe this would be our supplementary angle. Or if this was our line and we had to find the supplementary angle to 115, it could be this one. Or honestly, if we wanted to find us another supplementary angle, it could be anything that's 65 degrees so that both of those angles add to 180. But regardless, we'll put our initial one right here. So that would be angle, what was that? VZY, this one right here, is supplementary to VZX. It's the easiest visual one we can see right there. All right, now let's look at a couple examples using supplementary and complementary. All right, so find the measures of two supplementary angles. Underline those key words in the word problems, guys. It's really important. So we're finding measures of two supplementary angles. Well, I already know a supplementary angle adds to 180 degrees, so I should remind myself of that. If the measure of one angle is 6 less than 5 times the measure of the other angle. Okay. So we have two angles, right? So let's write angle 1, angle 2. We're going to figure out their measures. All right, so we know one of the angles is 6 less than 5 times another, but we don't know the other. So let's say x is angle 1, because we don't know it. But we do know the other one is 5 times x minus 6, because it's 5 times the measure of the other angle and 6 less. So now that we have these two expressions for our angles, we know each of them are equal to 180, so we're just going to make this an equation. So we're going to go 5x minus 6 plus, well, the other angle, because if we add both of these angles together, both of these here, they equal 180. And now let's just solve. It's like a normal equation. We're going to combine the x's and get 6x minus 6 equals 180. Then we're going to add out the 6 on each side because it's being subtracted, so we do the opposite. And so I'm going to come over here. That gets me 6x equals 186. And then I just divide out the 6 on each side. So I get x equals 186 divided by 6 is 31. We're not done yet, though, because we're supposed to find the measures of these angles. Well, we know x is 31, so that means angle 1 over here is 31 degrees. If we plug 31 here, and we did all the math, 31 times 5 minus 6, we're going to get 149. But I want you to recognize, don't write this down, that if you did 180 minus 31, because you knew the measure of the first angle, you would get 149. So you can do it either way. Okay, let's do this next one. Find the measure of two complementary angles. We know those are 90 degrees apiece, or they add up to 90. If the difference in the measures of the two angles is 11, so let's do this again, angle 1 and angle 2. Each of these angles are going to add to 90. We don't know one of them, but we know another one of them has a difference of 12. You could also do an addition of 12 and find the measure of the bigger angle. It doesn't really matter. Let's stick to it this way. So x and x plus x minus 12 is going to equal 90. Then all we're going to do is combine our x's. X plus x is 2x. Make sure you know that. It's not x squared. It's 2x. Minus 12 is 90. Then add 12. You get 2x. 90 plus 12 is 102. Divide out the 2 on each side. You get x is 51. We're not done yet. We have to plug it back in. So x is 51. That's right, 51 degrees. And whatever 51 minus 12 is, which you can do it either way. Remember, you can subtract 51 from 90, or you could just subtract 12 from 51. Either way, you're going to get 39. And those are the measures of our two complementary angles. Cool. Let's move forward. All right, perpendicular lines. These are lines that form right angles are considered perpendicular. All right. Perpendicular lines intersect to form 4 right, and just so you know, it kind of cuts off 4 right angles. Perpendicular lines intersect to form 4 vertical angles as well. Segments and lines can be perpendicular. 2 lines, got cut off there, or the other line segments and rays. So if you're looking at our example here, we have got line YW and line XZ, and they're forming perfectly at a 90-degree angle. And if that's a 90-degree angle, we know it's vertical to this, so that means they're congruent, so that's a 90-degree angle. And we know this is a straight line, so that's a 90-degree angle, and that's a 90, so basically that's what perpendicular lines do. They make everything 90 degrees on every angle. They're also vertical angles. We've talked about those earlier. Vertical angles. And so it doesn't matter as long as the lines intersect and form 4 perfect right angles. They're perpendicular. The symbol for, oh, sorry, I'm just going to skip this. The right angle symbol in the figure indicates that the lines are perpendicular. A little repetitive. And the symbol for perpendicular is read like an upside down capital T, as you can see right here. So let's look at an example. So example 1 says find x so that line KO is perpendicular to HM, line HM. So this is line HM. That means KO is perpendicular. If we can assume that, we need to find x. We have an expression here. We have an expression here. That's all we've got. Well, luckily I drew those green lines because I can already assume these added together are 90 degrees. So 9x plus 3x plus 6, add that all together, you're going to get 90 degrees. Okay? Add the x's together. 9x plus 3x makes 12 x's. Bring down your plus 6, you're 90. Subtract the 6 on each side. Bring your 12x down. 90 minus 6 is 84. Divide out the 12 on each side. And you get x equals 7. So we solved for x just like it asked. Perfect. Okay, example 2. Find x and y so that BE and AD are perpendicular. Okay, so if BE and AD are perpendicular, I can assume this is a 90 degree and this is a 90 degree because perpendicular lines make 90 degree angles. So over here, I can just add 6x plus 3x because if I add those together, I know they're equal to a 90 degree angle. Add those x's together, I get 9x equals 90. Divide out the 9, and I get x is 10. So I've solved for x. Let's come over here. I got 12y minus 10. That whole thing is equal to 90. Add the 10 on each side. I get 12y equals 100. Divide out the 12 on each side. I get y equals 100 divided by 12. That's ugly. Well, it's 8.3 repeated. Ugly. Or 8 1/3 if you really want to write it that way. So that is how you solve those. We solve for x and y, assuming that BE and AD were perpendicular, making all of these 90 degrees. Cool. All right, we're on our last page. Hang in there. Assumptions. So we need to determine whether these bullet points listed below are something we can assume or we can't. So we're going to write yeses or nos whether we can or cannot assume. So looking at this figure over here, can we assume that all of the points shown are coplanar? Well, remember that very first example we went over on these notes? Since they're two-dimensional and they're on this one sheet of paper that is two-dimensional and there's no three-dimensional shown, they're on the same plane. So yes, we can assume that. Can we assume that P is between L and Q? Yeah, because it is, right? We can prove that. Okay. Can we assume PN is congruent to PL? No. We would need those little congruent things, right? Keep doing that. Can we assume that QPO, that angle, and OPL are supplementary? Yeah, because if you add this angle and this angle together, they're on a line that is 180, so yes. That's what we learned in this section. can we assume that PN and PM are perpendicular? PN and PM. Well, no, because they don't keep going. And we actually can't prove that this is a 90-degree angle because there is no little box there. So no, we cannot assume that. L, P, and Q, can we assume that they're collinear? Well, we can assume because we can prove that they are all in the same line, and that's what collinear means. So yes, we can assume that. Can we assume that QPO, which is this angle, and LPM, which is this angle, can we assume they're congruent? Let me think about that. If this line continued, and this line, I guess they are vertical, but unfortunately the line segment kind of doesn't make it so that they keep going through each other. So I would say no. Because if this kept going and this kept going, I would say those angles can be congruent. But this is a straight line, and these angles don't necessarily intersect and keep going, so we can't assume that unless we knew. This is the only way we could assume that they're congruent. It would have to look like this. They would have to actually show that they are the same measure, because they are not vertical angles. If they were vertical angles, though, totally could be congruent. All right, moving on. What about PQ and PO? Are those lines congruent? PQ and PO. Are they congruent? Well, I can't really tell, and they don't do this, so no. Unless there were measurements or there were congruent lines through those lines, I can't assume that. Remember, we talked about in geometry, you always have to be able to prove it, or else if it's not in the figure, you can't assume. All right, LP and PQ. LP, line LP and PQ. Can we assume those are congruent? No, because, guys, we don't have those. Again, so we can't assume that. LMP and MNP. Does it say LMP? Is that even an angle? Oh, I guess you could assume it's this angle. Let's try that again. LMP. LMP. That angle, that's not really an angle in this. And MNP. So it's this angle and the other angle. Can we assume that those are adjacent angles? I'm going to write no. They don't share the same vertex. Those are two different vertexes, and they don't share a same side. So no, they are not adjacent angles. LPN. LPN. That's this angle here. Is that a linear pair with NPQ? NPQ. Absolutely, because there's a line. This angle plus this angle would equal 180. Those are linear pairs. Yes. That is an exclamation mark that went awry. All right, almost done. OPN. Gotta erase all this drawing. OPN. It's this angle. And LPM. Can we assume they're congruent? Come on, no, of course not. We don't have the little things here that say that they are. How could we assume that? If they're not vertical angles, they're nothing. What about ray PM, PN, PO, and line LQ? Did they intersect at P? Well, don't they all have P in it? Yes. They all intersect at P, right? Everything does. Okay, last example. And I'm over with this video. Over it. Determine whether each statement can be assumed from the figure below. Let me zoom in a little bit. So we've got, can we assume that the measure of VYT, which is right here, VYT, can we assume that that is 90 degrees? Well, the thing is, when I erase that, X, YV is 90 degrees because it has a little thing here. And this is a perfect line. So if that's 90, that has to be 90 because that would be a linear pair of 180. So yes. Let's get rid of all that drawing. All right, next one says, can we assume that TYW and TYU, so that's this angle and this angle. Can we assume they're supplementary? Well, they're all both on the same line, and this angle plus this angle would definitely make a 180 degree perfect line, so yes. Last question. VYW, TYS, TYS. So it's this angle and this angle. Can we assume they're complementary? Absolutely not. How would we know? We don't know the measures of those angles. No. All right. If you could do me a favor, I need you to start the 1.6 assignment. It's our last assignment. Then we're going to do test review, and then we're going to be taking Module 1 test. Crazy. All right. Good luck, guys. Ask for help if needed. Me and Mr. Mitchell are around.